We'll learn what is HashMap in Java, what is hashing, and how does HashMap's get and put operation works. HashMap is part of Java's collection framework since its inception in Java 1.2. Although it's part of Java's collection framework, it doesn't actually implement the collection interface. The HashMap is the implementing class of map interface, along with HashMap, concurrent HashMap, hashtable, linked HashMap, tree map, etc. Whereas the hierarchy of collection interface looks like this, the main difference between both of these is that the collection is simply a group of objects, whereas a map is a group of key and value pair. It maps keys to values. Now let's discuss the working of a hash map. Whenever we create a new hash map, it internally creates an array of nodes, also called buckets. Each node or bucket consists of four properties: hash, key, value, and next. We'll understand all these properties in details once we get to the working of the hash map. Let's first understand the put operation. Here we are putting the key C with value 1. Note that in our example we have taken the key as a string and value as an integer. Now whenever we perform the put operation, the program first finds the bucket or node in which our key value pair is supposed to go. This process is sometimes also called as bucketing. The default initial capacity of HashMap is 2 raised to the power 4, that is 16. Although there are separate rules for how this capacity can be changed and how the capacity increases, for brevity we will here stick to the defaults, that is 16 buckets. Now when we perform map.put c,1, the node is supposed to go in one of these buckets. Let's figure out how do we find the bucket in which this key value pair will go. HashMap works on the principle of hashing. Hashing is a technique to transform any object, in this case a string, into short fixed length representation. Essentially, in the process of hashing, we call the hashcode method on any object and it returns a numerical value for that object. Note that this shorter value helps in indexing and faster searches. Each object has a hashcode method. In the case of string, it is calculated using this formula. Now let's get back to our HashMap working. First, observe the way in which HashMap calculates the hash. It first gets the hash code by calling the hashcode method, then it uses the logical shift right and XOR operation. This is done in order to spread higher bits of hash to lower. This is discussed in detail in Java docs. Once we have our hashed value, we need to find out the bucket where we have to place our objects. The bucket index is found using n-1 ampersand hash, where n is the number of buckets. In our case, we have 16 buckets. Let's see our first example. For the string C, the hash value is 99 and bucket will be 16 minus 1 ampersand 99 equals to 3. Now that we have calculated the hash and bucket number, let's create a node using these details. As we have seen previously, the node consists of four properties: the hash, which in this case is 99, the key and the value, and the next node. The next is currently pointing to null, but we will get back to its working in the later part of this tutorial. Let's now place this node in the fourth bucket in our array. Remember, this is the node number 3 in zero index system. Similarly, for the second put operation, map.put f,2, the hash code for f is 102, and so the bucket number will be 16 minus 1 ampersand 102 equals to 6. So this will go in 7th bucket. For our third put operation, map.put aa, 3, the string aa will have hash code as 2112 and bucket number will be 16 minus 1 ampersand 2112 equals to 0. So this will go to this first bucket. For our fourth operation, map.put aa, 4, the string AAAA will have hash value as 2031775, and the bucket will be 16 minus 1 ampersand 2031775 equals to 15. So it will go in the 16th bucket, which is the last in our array. Till now, we have observed that our nodes were having different hash value and the bucket number was unique for all of them. Hence, we can observe that the next variable of all our nodes is pointing to null. But what happens if two nodes have the same hash value? Let's now see the tricky part. For put operation, map.put bb, 5, the hash value calculated for the string bb is 2112. Remember that we got exactly the same hash value in our third case for key AA. So key value pair is also supposed to go in the same first bucket. Therefore, after checking that the key is not duplicate, this node is placed after this previous node, which creates a linked list. Similar to the previous case, the key BBBB also have the same hash value 2031775 as string AAAA. So it goes in the same 16th bucket after the previous node. Now talking about the next variable in our node, observe that it's now pointing to the next variable for both our linked list. Now that we have gone through the put operation, let's see how HashMap's get operation works. Whenever we call the get method, the program will again find the hash value and bucket number using the same method that we have seen in the put operation. In our first example, map.getC, the hash value and bucket number are 99 and 3 respectively. So our program will search for our key in bucket number 3. However, since we know that two keys may have the same hash value, hence there is one more step in our get operation. The program will use equals method to check whether two keys are equal or not. For our second example, map.getBB, the bucket number calculated using similar methods is 0. But when our program looks for our key in the first bucket, the equals method returns false for the first node. So the program looks for the second node in this linked list. Since the equals method returns true for the second node, we get our value. Hence, in this video, we learned what is HashMap in Java, what is hashing, and how does HashMap's get and put operation works.